Hi, everyone, and welcome to today's SQL Office Hours. Today, we're doing something a little bit different. I'm really excited to have a guest speaker. That is Ronald, who is a developer, creator of Jobrunr, and a Belgian beer lover. So he's going to show us some hopefully cool stuff about using AI vector search in Oracle Database 23 AI. So with that, I've also got my colleague Martin Bach, who's going to give some background about how this all came about. So I think at this point, I'll just hand over to Martin and Ronald.
Yeah, thank you so much. Yes, as you say, this is quite exciting, and we're looking forward to seeing Jobrunner being used to perform vector search with the database. And having said that, I'd like to put out the safe harbor statement real quick and go over to introduce our session today. As Chris was alluding to, Ronald is going to drive this, and we're going to do no slides almost, apart from a few intro slides that you're seeing right now. And then we're going to do a live demo, and that's going to be the fun part where where we do this. I very much like live demos and coding during presentations a lot more since I've attended some of the cool developer events that I run. And having said that, we've got Chris, as you know, myself as your host, and Ronald, who's going to run the show, so to say. And we got together a little while ago in the context of what you're seeing on the screen right now. So we had a few exchanges on the forums. The Jobrunner team was trying the 23 AI container image, and they were making good use of it. And we found out, something isn't quite right. And we went back and forth, and it turns out that Jobrunner found a regression in the code that's been hibernating there for quite a while, and we're very grateful for the contribution. So thanks to their input, we've been able to go back and fix this regression that's been introduced, I don't know, 20 years ago or something. So that was quite remarkable, and we kept chatting, talking back and forth, and we had good feedback from the Jobrunner team. And then we thought, hey, wouldn't it be cool if we could do something together, just to show that there is interesting new stuff out there for the developer community. And you see on the screen what 23 AI kind of has to offer in terms of marquee features. And amongst all of those, what we're going to do today is AI vector search, because there is some great synergies between AI vector search in the database and how you can make use of Jobrunner in order to get this done. And having said that, I'm now going to give it over to Ronald, if you would like to run us through that slide. So what is Jobrunner? I'll do the slides. You just say next, and I'll do the animations. I start with that one.
No worries. So yeah, what is Jobrunner? Well, it's an open source Java library for background processing, as you can see on the screen. And I started it a couple of years ago, I think right before COVID, as a hobby project initially, to calculate the wages of a lot of Belgian employees and to make sure that that would run efficiently. And it, of course, had to integrate really nice with the rest of the Java community out there. So that's why we have a Spring Starter, a Quarkus extension, and also Micronaut integration. And we really try to be as broad usable as possible. So we try to integrate a lot of databases, SQL and NoSQL databases, and of course Oracle is one of them. Then there is inside the Java library, there's a dashboard where you can see whether your jobs are going well. There are metrics. There is also failover by default. So this is all cloud native. If one of your nodes decides to crash when you're processing jobs, well, it doesn't matter. Jobrunner will automatically recover, and another node will continue with processing jobs. And what do we allow? Well, fire and forget scheduling. This is what we used a lot when we had to calculate all the wages. So at the end of the month, we had one recurring job that looked at all the population of people that worked, where we had to create the salary slip. And then we just spawned a lot of jobs to make sure that they each had their salary calculated. Of course, we also have scheduled jobs, recurring jobs, and other stuff. And then initially the idea was that, open source. And back then I also created a pro version with a little bit more features in the hope that if a license ever would be sold, I could take out my wife out for dinner because, she allowed me to work 8 months on this without any income. But now we are a 5-man company already, so I could not have imagined open source growing that hard, to be honest.
That
So
sounds like a good story.
that's a little bit the story behind Jobrunr. But
Okay.
today it's going to be more of programming and demoing Oracle AI, Spring Boot, and Spring Data JDBC, and of course Jobrunr. And I thought, what is a cool application? Well, as a developer, I sometimes have tickets coming in, but often these tickets may be duplicates. So let's try to make our own life easier in this case. And as soon as a ticket is created, let's make sure that we see whether there are any other similar tickets so that we can quickly find a resolution and solve the newly created ticket. So that's a little bit the idea behind today's session. So if it's okay,
Yes.
Martin, Chris?
Yeah, exactly. Just one thing before we start. I'm going to stop sharing. You can start sharing your screen. I just wanted to let the audience know that when we prepared for this, we discussed when we want to take questions. So I know questions during presentations are sometimes a little tricky to handle. We've got the webinar interface. So you guys, if you've got anything you would like to ask, put your question into the Q&A. We've got people both from our side, from Oracle's side, and also from Jobrunr's side, answering questions as they go and happen. But I'll also, if there is something really cool and interesting, I'm going to wait for an opportune moment and hand that over to Ronald for discussion. So we try to make this as interactive as possible. So don't be shy, hand us your questions. And with that said, I'll stop sharing. I should have stopped sharing when I started talking about that.
No worries.
Our technology.
And everybody should be seeing my screen and my Gmail, I think even. And now I switch to IntelliJ. So I'm gonna really start from scratch. So we start with a blank vanilla Spring Boot project in IntelliJ. And for this session, we are going to use Maven. I already gave it a name. Let's just hit next. And then, of course, the things that we need to add to our Spring Boot project. So I'm a big fan of the Spring Web and also about Spring Data JDBC. Then, of course, we are going to use the Oracle driver. And I'm really liking the recent combination of Spring and containers. And so we're also going to add Docker Compose support. So let's already create this project. And let's go again to the POM because we need to add a little bit more. The first thing, though, that I'm also going to do, because we're doing the vector search, is the Oracle driver is currently by default by IntelliJ marked as runtime, but we will need it also in compile time. We are going to be using the Oracle UCP driver or connection pool. And by the way, I just learned that this was a thing. In the past, I always used Hikari. Perhaps, Martin, if you have some info about UCP, because I think it adds a lot of benefit for making sure that Oracle is high available when using Oracle as a database.
Yeah, there's an interesting point that you mentioned. I came across UCP a long time ago, and I've always found it really useful. But the config in Spring, I had to do a little bit of research in order to get this done right. I think we could do some more blog posts about the integration. with UCP and also in Spring. But Hikari, I know that somebody from the JDBC team in Oracle, his name is Kwasi, he wrote a few blog posts about integrating Hikari as a connection point with Oracle as well, if people want to stick with that.
Yeah, for me, to be honest, that wasn't too difficult. So yeah, let's see how it goes. But to be honest, like Chris earlier mentioned, I'm also a Belgian beer lover, and it's already 5 o'clock here in Belgium. So by the end of this evening, I would like to go to have a beer. And what I did, I'm going to cheat a little bit. I'm going to copy some files over here to make the demo go a little bit faster. So Jobrunr copy, but don't worry, I'll explain everything what I've done. So the first thing that I've done is improve the compose file that was auto-generated by IntelliJ. And this is, of course, using the latest 23 Oracle AI database. I put in some environment variables to make sure that we can connect, and I added a health check. And then here is the interesting part. I mount 2 folders inside the container. One is the model, which I'll get right back to, and then the other one is the container entry point. And what does this do, in fact? Well, this directory will automatically be read by the Oracle AI Docker container, and each of the SQL files in there will be executed. So this allows us to really easy set up the Oracle container. And what you see here is, well, there are some files that were also put over being set up Oracle. This was a really nice trick that Martin shared with me to improve a little bit the performance. We set it all in when running on, for example, Mac. I increased the redo log size. This is definitely not necessary for the demo, but yeah, I copied these files over from another test environment. And then this is the interesting part. Here we are quickly creating a table, tickets, and we add an ID, of course, a version, subject, description, the created at, a resolution. So resolution, when the ticket is actually resolved, we will update the resolution. Then we have a status and last but not least, the embedding. So this is where the interesting part later on will happen. And then there is one other file called load model. And the thing that it does is, in fact, it grants some extra rules to our test users, being the developer role and the mining model. And then what we do is the folder that earlier on I mentioned inside the Docker Compose file, well, we point it inside the SQL. We create, in fact, DM dump, so data model dump directory, and we make sure that the user can read, or test user can read it. So, and then what we do is we, in fact, import an ONNX model. And ONNX stands for Open Neural Network Exchange. And the cool part about that is that you can just load any ONNX model right inside Oracle and use it inside your database. So that being said, if I do Docker Compose up, we should have already a running Oracle container with all the setup already done for us. And here you can see it's loading the all mini L12 V2 ONNX model, which is in fact a model for embeddings and vector search. But now let's go. Yeah, I copied some other files. I will show later. I will go into them, but yeah, to discuss everything now, it's a little bit too early. And of course, we are going to talk about tickets, issues, and stuff like that. So let's get into it. I'm gonna create a class which is called ticket in this case. And this is going to live in our table tickets. And I'm going to add a protected constructor for it for now, ticket. And it has a UUID ID, an int, which will be the version. Then we have a string, which will be the subjects, a string for the description. Also, we want to make sure that we know when it was created. There is, of course, a status that we need, ticket status. This class does not exist yet, but I'll create it afterwards. The resolution once we have it solved, and I think we should have everything in this case. Let's see. Otherwise, it's always the interesting part. I don't do live coding on my own. I always call it mob coding. So if you ever see an issue, do not hesitate to reach out and say, hey, you forgot something or so. But yeah.
Looking good so far.
Yeah. So we create the ticket status and we keep it simple. It has two statuses, possible statuses, open and closed. And then we are going to bind these two, we're going to create variables for it. Voila. And then, of course, because we're using Spring Data JDBC, there is some stuff that we will need to add. The ID, so that Spring knows that that's the actual ID that we're using, and the version, so that our entity is version. So we automatically have optimistic locking and these kind of things out of the box. And then let's make sure that we can access everything. And then I forgot, like the ticket status, of course, well, that will be changed. And that's also the reason why I am not using a Java record, because otherwise you could say, hey, this is perfect candidate for Java record. But no, this one will change. And the resolution can also not be final because, yeah, we're going to update ticket. And then I am going to make sure that we can actually create tickets. So ticket, what we do is a new ticket. And then we will need the string subject. And sometimes IntelliJ just wants to propose too much because nothing more. There is nothing more that we really need to create a new ticket. So return new ticket, UUID.randomID. The version is 0. We pass the subject, we pass the description. This is instant.now. And the ticket status is, of course, open when we have it. And the resolution is null because we don't have a resolution yet. 0. That should be this one. Oh yeah. And then the important thing also, we need to tell Spring that it should use this constructor. I'm not 100% sure, in fact, because there is only one, but yeah, never hurts to add it. So this is our domain object. Now I'm going to create the model. I like clean code, so we are moving this one there. And then I'm going to create a new Java class, which is our ticket repository in this case. It's an interface, and it extends the root repository of Spring Data JDBC, but of course we don't have strings as IDs. We have UUIDs, and this is a repository. I think that should be it for the moment. And this is also not in the right place, so it needs to be here for me. And then we need to import a class, of course. So, okay, this is going well. The next thing that we then need to do is create the controller, the REST API. And well, let's quickly also add it. So this is a REST controller, and the request mapping that I want it to have is /tickets. And I always try to start easy, try to make the minimal thing working, that can work. So the first thing that I'm going to do is make sure that we can just list all tickets. It will be empty, but at least we know that everything is set up, like the connection to the database and stuff like that. So let's go for that. So we have a list of tickets, get all tickets or get tickets. And with Spring, we can even add like the possibility to query on the open or the close. So at query param or query, it's request param, sorry. And by default, this would be required, but now we're going to make it not required, and the default value in this case will be open. We only want, if we don't pass the request param, we want the open tickets. And this is then ticket status. We do the necessary imports. Of course, we need our repository. And then here we can start using it. We're not going to use the find all because then we would need to filter server side. Let's use Spring Data GDPC to filter in the database, of course. So we can do find tickets by status. And then we can just pass in our status. And this, we want to have list tickets. And we create the methods. And we just return it. Okay. It's not too bad, I think, for the first iteration. Let's see whether things work. Yeah.
I really like the way how you do this in Spring Boot, where you have convention over configuration. You don't. I remember when I first started working in J2E, the XML descriptors that would kill you.
Ooh. Yeah.
This is so much cooler.
I'm so happy that we're behind all that, because I wouldn't. Then we would have at least needed 3 hours for this
Yeah.
I think.
Then we would show XML to people for about an hour. Now we've come a long way.
Yeah, indeed. All right. So what I also really like about IntelliJ, by the way, is that it has the opportunity to just write all your HTTP requests in a file called HTTP, and it allows you to do get posts and whatever. So let's see what happens if I do it like this. And this is not the result that I expected, to be honest. I think it's because in our controller, of course, I didn't add a get mapping, and we just need to add slash. And this is this is the one that I need to run again. So let's see, let's pray to the demo codes. Yeah, this is better that things work. So we don't have any single ticket for the moment.
The important thing is we've got the right response code.
Yeah. Perhaps also what I did to make sure that the application successfully connected already to the database is again the copying of files that I did at the beginning. Well, what did I need to do to make sure that UCP and is used by Spring Boot? Well, what we do is we specify the data source with the URL, the username, and the password, and then we just specify everything related to the Oracle Universal Connection Pool, and that's it. So yeah, wasn't too hard. Perhaps this one is an interesting type, which I want to get back on later on when we do the vector search. But for the rest, yeah, it really works out of the box. Okay, so now let's make sure that we can save a ticket. And here we return a single ticket, save tickets or submit tickets. And then we have two request params that we are going to need. The first one is the subject, and the second one is the description. And what we are going to do then, we are going to do ticket dot new ticket subject description. We save it inside the Spring Data GDBT repository, and then we just return it. And if I restart this one, we should be able to already save a ticket and list the tickets again. So what I'm doing then here in this HTTP request, well, now we are doing a post, and I was rather lazy. I'm not using JSON here. I'm using the good old, back in the days, really old. And then I realized I'm getting old. The www form URL encoded. We pass the subject and the description. And from the result, because we, perhaps what we can do still here is return response entity of ticket. That way, and we're 100% sure that we return an HTTP 200. And from the response, which is in fact a ticket, we get the ID, and then we save this ID in IntelliJ so that we can later on reuse it. And hooray, I think we were able to save our first ticket. Let's see whether I'm not lying. So yeah, we have a list of tickets that we can already create and fetch. So that's really, really good. And now we're getting into the interesting part. So everything related to the vector search. And to do so, well, what we're going to do is we are going, the moment that a ticket is resolved, then we will update the embeddings of that ticket. So we will calculate, the vector embeddings. And then the next time when we are receiving a ticket and we go to the detail of that ticket, we will make sure that all similar tickets will be shown in a way that the most similar ticket will be at the top. So that's a little bit the goal of the session. And to do that, we of course need to be able to resolve the actual ticket. And we are going to introduce a new class for that because I have not encountered any project in my life in Java where there wasn't any kind of service being used. So in this case, we'll introduce the ticket service. And we are going to make sure that we can resolve the actual ticket. But to do so, we also need, of course, the ticket repository. I'm going to add a constructor. And public ticket resolve tickets. And we are going to add the resolution. This, of course, will return again a ticket, and I have a small typo. So the first thing that we are going to do is fetch the ticket. We of course need also the ID of the. And if it's not there, yeah, then somebody is doing something fishy, so we throw an exception. And then we are going to do ticket.resolve. And here later on, we will create a Jobrunner background job to update the embeddings and make sure that we have the embeddings saved within Oracle, so that later on we can do the matching. But for now, I'll leave it to do. And then we return the ticket again. So to resolve our ticket, well, that's really easy. What are we going to do? We are going to put the resolution to the actual resolution, and we're going to change the status, of course. So this dot status, it's not open closed, and I like Fluent API, so sometimes often I just return the object itself and to do. So that's that. This needs to be a Spring Boot service. This can be final. And then we can go to our controller. And we can now resolve the actual tickets. But we need to pass in the ID. And it's going to be, this is going to be the path. And we say resolve tickets. And then here I have a path variable, which is UUID ID, and then the resolution. Like this. Of course, now I also need the service that I just created, so let's quickly add it. Constructor. Voila. And then we can do ticket service.resolve ticket ID resolution, and we return again the same ticket. Okay, I'm curious. Let's restart the demo again. And if we go to the HTTP of the demo, so we have the created ticket. I wonder now, can we still view the tickets? I think it lost its. Ah, no, this is a method we don't have yet. Yeah, this is to view the one single ticket. So this is something we're going to add later. But I should be able to resolve it. And yeah, the ticket I created earlier on was, hey, Jobrunner is not working. I have a job not found exception. Well, in that case, if you have a job not found exception, it means that the signature of your job changed and that it cannot be found anymore in the code. So, but let's now try to resolve it. And it worked. The status is closed and the resolution is mentioned. So this is already Cool, this is good. Then the next part is actually adding the necessary methods to save the embeddings. And I also prepared this a little bit. So I am going to put some queries in here, which will run, will go through each and every one of them. But that way, we have everything already set up and we can go have our Belgian beer in time. So the first thing that I'm adding here is compute embedding. And what does that do? Well, we ask Oracle to calculate us the vector embedding using this model. And this is the model that we loaded earlier on inside the container. And we pass in the text as data. And then we will get back, in fact, the double array, and which is, in fact, the vector for this text. And then later on, we also want to find similar tickets. And similar tickets will have an ID, a subject, a description, of course, their resolution. And what we do is we calculate the vector distance related to the existing ticket based on the subject and the description again. And then the important part is, and this is really cool, is that we can combine like vector search with existing SQL, like we all know. We can just say, okay, we only want to do this, of course, for the issues that are closed. And then we order them by score. And then we only want the top X amount. And then last but not least, we also need to update the embeddings. And this is the first part that we're going to do. So we are going to update the vector embeddings for that ticket inside our service. For now, I'm just going to comment out this part, but yeah, we can already compute the embeddings and update the embeddings, and that's what we now need to do. And this is also where Jobrunr comes into the picture, because our tickets here are really, really small, but let's say that you have like a lot of documents or a lot of content that you want to ingest. Yeah, well, that sometimes can take some time. And if you want to make sure that you're not overloading anything, well, you can easily create jobs that will be then processed one by one, and yeah, we're not overloading too many stuff. So let's now add some Jobrunr stuff. And what I'm going to add is the job scheduler. This will allow us to create and calculate the embeddings then in a separate background job. So here what I do is job scheduler.enqueue, and now we need to pass a Java lambda in this case. You can also override existing jobs or so, but here we need a lambda, and what I'm going to do is I'm going to create another method here, public void update embedding. And in this case, I am only going to pass the ID of the ticket. That's all. And then we again fetch the tickets. And then we need to using the repository, so ticket repository.compute embedding, we need to have the actual text to calculate our embeddings. And in this case, I'm going to create a simple method here, public string get content. And I'm going to pass in the ticket. And what we're going to do is we're going to return the subject, and we're going to append, in this case, with perhaps a system.line separator, the description. And then what I can do is we call this method tickets. So we have the actual embeddings. This is the embedding. And this is in fact returning a double. And this is, yeah, this is where I'm also not a big, how must I say, specialist in everything AI and stuff. But yeah, of course, these are vectors. So this will return an array of doubles. And that's why here in the application properties, we're going to set up a property and we're going to say to Oracle, hey, by default for a vector, which is what we created here, the embedding is a vector. Well, by default, I want you to return a double array. And to do so, we also need to make sure that Spring Data GDPC knows how to get the double array from Oracle, because we get back, in this case, an SQL type, if I'm not correct, and then we can, or no, this is the other way around, sorry. So the double part is going to be returned fine, but once we want to save the double, the embeddings inside Oracle later on, then we need this type of converter. So we now have the embedding. So this is a double array. I think we can cast this safely. Here I need to make sure that this is correct. And now we can do ticket repository update embedding of the ID and say like this out, successfully updated embedding for ID. Yeah, let's not do sysout private static final logger is logger factory get logger ticket service dot class, and we just say logger dot info, something like that. So we can now do this. And what does that mean? Well, we can pass the lambda, hey, update, no, this will not work, update the embedding. So for ticket.id. And then perhaps a small side note, why am I only passing the ID and not like the complete ticket? Well, this will automatically be serialized. Yeah, this in fact, the lambda, we will analyze it and then we will serialize it as JSON. And the idea is that you make your arguments as small as possible, because once this will be run in a background job, in this case on the same server, it can even run on different servers. But if we would pass the complete object, the complete entity or model, well, we would bloat the tables that Jobrunr is using, because that whole ticket object will then be serialized as a JSON as an argument. Whereas here, as it is a background job anyway, we can fetch it easily from the database using the ID. And the thing that we will now save inside the Jobrunr jobs table is really small, and we will not bloat our tables a lot. This is one of the best practices. The reason I'm mentioning this is because we've seen users putting in entities here being 100 megabyte size, and then of course, oh, my table is growing so fast. Yeah, voila. So I think we have now everything up and running. The job scheduler is IntelliJ is complaining about the job scheduler. Let me double check. And he is correct. The reason that he's complaining was that I didn't add the Spring Boot tree starter, but only Jobrunner. So if I do it like this, we reload Maven, then our Spring Boot starter will make sure that automatically the job scheduler will be available for auto wiring. Then by default, Jobrunner will allow you to create jobs, but it will not show you the dashboard, and it also will not do any background job processing. Because this is, like I mentioned before, meant to be cloud native. And what do I mean with that? Yeah, let's say you have an e-commerce platform, you have your front-end service serving requests where you want to show the products that you're selling. But on the back end, you want to do all the processing, like sending invoices, creating order pickings instructions. And by default, we are really protective. With that, I mean, if you spin up a new container, well, you don't want this front-end container to be automatically processing jobs. Only the ones at the backend should process jobs. And that's why by default, these variables are disabled. I'm now going to enable them. Let's now see what happens once we do that. Let me double check whether I've got everything. So we can compute the embeddings, we can update them, we have the ticket service that can resolve them, we log. I think this will go to a no-op logger though, because of we didn't add SLF for logback. Perhaps we should quickly add logback also. Dependency, logback, classic, voila. So we have that, and then the only other part that I want to double check is we can resolve, and this should do everything. All right, let's see what happens there. Yeah, this is already good. So the other thing that you saw now is that Jobrunner by default will create all the necessary tables for you. So you can by default we do it for you. Of course, you can opt in and provide all the tables yourself. But yeah, this is the easiest, especially during a demo. And then if I go back to our tickets, we have it here. And yeah, we have now one ticket which is not, where the resolution is not okay. So we're now going to create a new ticket post. Okay, it's created. Then I'm going to resolve the ticket. And I'm really curious. Yes, respond, it looks good. And if I now go to localhost 8000, I should have a job which is in queued. And it already succeeded. So what we did is we created the job. Jobrunner noticed that, and then it started processing it, and yeah, it updated the embeddings. So this is good. And then I'm gonna share a personal note quickly. This is also so cool in IntelliJ, by the way. These days, if you go to here, you can automatically add directly you can add the connection to the database. So sometimes it doesn't take it completely, but test. Apply. No, this is not what I wanted. Close. Oh yeah, it's doing it. Yeah. And what you see here, we have now quite some tables. These are all the tables related to the ONNX model to generate the embeddings. These are the Jobrunr tables. And then we have the tickets. And one thing that cost me a little bit of time loss is that the embedding here, it shows an Oracle exception, but it's in fact the data is there, but IntelliJ uses the GDBC driver, and it's not allowing you to view the actual embeddings yet. So don't worry if you see this, it's normal. I hope they soon update the possibility that you can also see the actual embedding here. And then we go to the last part. Now I want to view an actual single ticket. And if I view a single ticket, I want to see, hey, is there any other ticket related? And let's see whether we can then solve the issue of the user faster than we would do normally. So for that, I am going to add a new get mapping here in my controller. And we are going to add this thing again. And we need the auth variable ID. And let's do this via our service in this case. So what I want to do is do ticket service dot get ticket ID. And this is, of course, not implemented yet. Now I'm going to use something else that I already prepared. It's called a similar ticket result. And what is a similar ticket result? Oops. It's like tickets that, of course, match the ticket that was recently created. And this is a simple record, and it's a projection. So what does it have? Well, it has the ID, the subject of the other ticket, the description, the resolution, and how much it matched the ticket that we are viewing. So what are we going to return? We're going to return another Java class, in this case, ticket view, let's call it, add. And it has, of course, a constructor where we pass in the ticket, but also a list of, and perhaps I should copy this record to that class where it makes more sense. Similar tickets. Voila. Constructor, no, it's not what I want. So import a class, it's that. Then we are going to bind these constructor parameters to fields. So that way we have it. Voila. And then we go to our ticket service. And now we have the other methods that I prepared here. So what we're now going to do is just calculate the vector distance, which is really easy using Oracle here. What we do is we calculate the difference between the text of the latest ticket and any tickets that already saved. We only want the ones that are closed. We order by score, and then we only fetch the top X amount. So how do we use that? Well, what we do is we again get our ticket. Then using the ticket repository, we can now find the top K by embedding, and I only want 10. And this method can go down. And of course, we need to again pass a vector in this case. And how can we get that vector? Well, it's in fact this what we need to do again. We calculate the embeddings in Oracle. and then pass it along, which will then return the similar tickets. Similar tickets. And then what we can do is we return a new ticket view, and we pass in the original ticket that was created, and of course also the similar tickets. Voila. Of course, you could do all of this inside Oracle itself, I think. The moment with a trigger, that the moment that the ticket is created, you already compute the embeddings. But yeah, here I try to get things easy. And then we have that. So what we can now do is we have this ticket, and this is now a ticket view. And what I'm now going to do is I'm going to reference entity OK of the tickets. And then duck. This we don't need. All right, let's see what happens. Since we're have the Oracle database kept on running within with using Docker Compose. Now you see that the actual Jobrunner tables are not created anymore, of course, because they're all there. So that's done only once. Let's go back to our HTTP. So if I now view a single ticket, I'm really curious. Not accessible. This is not what I expected, to be honest. Do we have an error? And this is where the live debugging will start, probably. Let's first go back. I am curious whether this one still works. Okay, we have open. But I see that for some reason that our tickets all are opened, although we resolved them. So this is a bug, and if anybody from the group knows what I've done wrong, I'm more than happy to have your help at this moment. Ticket resolve. What we do? Of course, we don't save the tickets.
I was about to say something about committing eventually that, because it seems like you rolled back whatever you did.
Yeah, indeed. So we need to resolve it, of course. Thanks for the help, by the way. Yeah, the good thing is that we don't do anything strange transaction-wise. And yeah, ideally we would add a transactional support here, but yeah, demo and yeah, Spring is doing it for us automatically here. So normally this should all work. So what I can do, I can now resolve those tickets. How am I going to do that? We get all the tickets first. Bloop. I'm going to cheat a little bit. And then we are going to I'm going to comment this. And then I'm going to put this variable here now. Okay, let's see whether it's worked this time. We have the ticket. Of course, it works, because I thought, oh my God, the ticket is gone.
Yeah, it's closed. It's closed. You're not telling it to get the closed tickets.
Okay, let's close the other one. And so we also do it here. Voila. That's also closed, so that should be okay. Again, we should have 2 jobs now. There is one still running, so it will be calculating the embeddings. Now I'm curious, did I save the actual embeddings? Yeah, this is going to work because we update the embedding, so that should be good. And then what we can do, and I'm curious now, not accessible, acceptable.
It's probably again something with the ticket ID.
I don't know, to be honest. Tickets. I think this is more related to Spring Boot, to be honest. Controller, get ticket path variable ID. Okay, so yeah, the demo codes are not always 100% nice for me, so I'm going to go to my backup plan, and just as a first step, I'm going to make sure that I have this one. That's what we do, yeah. So get tickets, similar, ticket view. Let's see what happens. Otherwise, we completely switch to the solution part.
Now it's complaining about find similar tickets.
Yeah, it's because of the name, ticket service. Yeah, okay.
I think the variable name is different.
Yeah. No, what I did in the here, what I can do now here, because here I did the calculating, the finding of the similar tickets. Yeah, this is a live demo. And the first time I did it differently than the last time. So what we here can do is indeed ticket service, get ticket ID, and this will already have, this is already the ticket view. So this what is now all done in the ticket service, in fact. So, yep. Curious what this will do. Last try. I need to be here. So let's see what happens now. No, okay. Backup plan completely. Terminal. Otherwise, because it's almost due time, the compose down. I'm going to do the same thing here. I will make sure that if anybody is interested later on what's going on to give the actual input, but yeah,
Yeah, it doesn't know about the compose file.
Yeah, indeed. This is the demo. Wait, I need to have a new here. This is why I'm going to compose up. So this will now do a little bit the same thing. It's creating all the tables, loading the model. I think the database should be ready to use. Let's run it. And then demo HTTP. So since it's a new database, we will need to create a new ticket. And that's created. We can now, hopefully, crossing my fingers this time, view it. And here what we see is the ticket is of course in status open, but since we didn't resolve any other tickets, we don't have any. So now let's resolve that ticket. Now it's closed. And if I would now have a look at that exact same ticket, which is resolved, well, the nice part is then, it's not, it's giving me an internal server error. This is parameter score must not be null. Ooh, now I'm completely lost. And this is where? Ticket repository, so parameter score must not be null. Is the ticket also not saved here then in this case? I'm wondering. Of course.
Has it created the embeddings? Because otherwise the
Yes.
vector distance wouldn't work.
you are completely correct. That's the problem. So if we refresh, it's not, yeah, nice thinking, Martin, indeed. Because here, we didn't enable Jobrunner yet. So let's start it again now with Jobrunner enabled, which will then create the embeddings, and then we will be able to actually see the solution. So I am going to resolve the ticket again. It's now closed. If we go to Jobrunner, we should see an actual job. There it is. Succeeded, already succeeded. And the previous job now also succeeded. And if we now go to the actual ticket, drum rolls, please, demo gods. Yeah. What we see is, the ticket and a similar ticket, but what it returns in this case with a score of 1, which is perfectly correct, is that it's returning the same exact ticket. We now create a new ticket with a different subject. So job running is having troubles, and when I'm running a job, I encounter a job not found exception. Well, then let's see what happens in this case. So it's created. And now have a look at that ticket. I see a different result. I see now similar tickets, but with a different score. And the cool thing is I can now easily look at that resolution. The score is really high, so I know that it is probably the right answer, and I can just answer that one and be a lazy developer. So this is all good. We can now use the vector AI search. But what if, and this is the last part that I'm going to demo, at the end of each day, you would like to see a daily report of the created and resolved tickets. And what I did is, here I created Jobrunner job, and it's annotated with @recurring. And what does it mean? Yeah, each night at 10 to 12, I hope nobody's creating any tickets anymore in the last 10 minutes of the day, to be honest. Then we take a since, we calculate the since, which is the local date time now. We put it to hour 0 and minute 0 at the system default zone. And then we have an instant. And then I created another method on my Spring Data repository, which is list ticket, find tickets by, created that after. And this will then print the details of all the tickets. So if I go to the Jobrunner dashboard, we can have the send daily report, can trigger it, and a new job will be enqueued, which is already here. And by default, Jobrunner only checks for jobs every 15 seconds. This is, of course, configurable. I could have put it a little bit faster, then we wouldn't have not to wait so long. But what we now see, hey, all the tickets that were created today, and I need to go here, is these tickets. And voila, I don't know if there are any questions, but that's it. We did.
You did it.
Oh.
And yeah, don't fret it. Live demos. I thought that was really cool. I learned a lot. And I think the end result is pretty cool as well. As you can see, there is a pretty interesting use case for this technology. We only have got one question, and I thought I'd leave this to the end because it compares Jobrunner with a database internal technology, and that's a package called DB Mesh Scheduler. And why would you use one over the other? I don't think there is a kind of right answer. The use case to me depends on your background. So if you like with your background, you're a Java developer, you're really good at using Java tools to interact with a database. So that would be natural for someone with that background to use your technology. Whereas if you've got a database developer with a strong database background, that person might probably use DB Mesh Scheduler to schedule things asynchronously in the background. There's no right or wrong answer. It depends, I guess, what you want to do
Yeah.
and what you know and what you're comfortable with.
Yeah, indeed. I think your answer is perfect. The only thing I want to add, perhaps, is that sometimes you have a lot of business rules which are only available in your application, being Java, .NET, or I don't know what. And then it would make more sense to have those business rules and have the scheduling perhaps part. It's a matter of taste, also personal tastes.
Yeah, and as you say, if you can only integrate using Java as an extension mechanism for your ERP system or whatever,
Yeah.
then I guess that's a no-brainer. But I think yes, that should answer the question. And that was actually the only one we had.
Okay.
I think everyone's been pretty amazed by your coding skills, so that was pretty cool. I liked it a lot.
All right.
Chris, do we have anything else that we need to do before we wrap up?
No, I don't think so. I don't think so. It's great to see you, Ronald. I think it's a good way of integrating all those technologies together and being able to see how I like the little thing at the end where you could find all the stuff for the day and see whether or
Yeah.
not they were similar. That's quite a neat application of this.
Yeah.
Yeah, the only thing I've got left to say, obviously, thank you, Ronald, for joining us. It's great to see people doing some
Thank you.
interesting, cool things with these technology. And just say to everyone, people who are attending, we're going to be back to normal time schedule for the next SQL office hours. So it'll be the 15th of July at 2 o'clock UK time is when that's scheduled for. Still planning exactly what we're going to be covering, but those of you who want to join for the next one, hope to see you on the 15th of July. Otherwise, anything final comments before we go, Ronald?
Yeah, I do. In fact, perhaps we have also an announcement to make, which is, I think, I'm really proud of, proud of. Just we are soon about to release the new version of Jobrunr 8. And one thing, like we all know that training these LLMs, updating RAG, it takes a lot of CPU cycles. It takes a lot of time, especially if you have huge content on in your company. So what we're adding in Jobrunner 8 is carbon-aware job processing. And that's perhaps a difficult term to explain that. What we will do then, and in the first iteration, I'm afraid it will be Europe only, but what you will be able to do is schedule certain jobs using a margin. So you can say, okay, this is the time that I want it to happen, but it can happen 2 hours before or 3 hours later. And then we will look at the moment that the least amount of carbon will be generated using data from the European energy grid. And based on that, we will then schedule the job at the optimal time.
Pretty cool.
Yeah,
Very cool.
I'm really proud of that. Yeah. That's we hope to release the beta in the next somewhere next week.
Okay, great way to help improve our energy efficiency and help address some of these carbon issues. That's great.
Yeah. And the main thing that we really strive for is to make this as user or developer friendly as possible. So the way to do it is exactly enqueue, and you just say the period enqueue carbon aware, and that will be it.
Very cool.
Yeah. Thanks for
thank you for the demo, and I guess that's it.
Yeah, thanks for having me.
Yeah, you're welcome. Alrighty then. So in that case, well, yeah, everyone who's joined us, we'll hope to see you again next month, and maybe we'll see you sometime again in the future, Ronald. All right?
Yeah.
Okay.
Thank you. Bye.
Thank you. Bye-bye.